So now let's look at the applications for the indefinite integral. So the application which is called the basic differential equations. Okay, so we use example. We know that the derivative of y is equal to 2x. So we want to find y. Okay, so here we know that whose derivative, so we want to find y such that the derivative y equals 2x. So y is actually equal to what? Equal to the integral of 2x dx, right? So the y is the antiderivative of 2x, right? So it can be written as the integral of 2x dx. So which is equal to whose derivative equals 2x. It's very simple, right? It's equal to x squared. But this is just one antiderivative. We need all the antiderivatives. So we need to plus a constancy. So don't forget to plus a constancy. This is very important for the indefinite integration. So you see we have infinitely many choices, okay, solutions. If we have the equation which involves some derivatives, okay, this kind of equation is called differential equation. Okay. So how to solve this kind of differential equations? This is very simple, right? The left side, the right side is just a function of x. How to solve this kind of differential equations? Because you see the left side we use the Leibniz notation, so we can treat this one as a what? As a fraction, right? dy over dx. So we multiply dx on both sides, then you will have dy equals f of x dx. We write as a, are you familiar with this form? This is called the differential form, right? Differential form. So what's the next step? So we take the integral on both sides. Right? What is the left side? So here is the convention. If there is no number here, that means there is a 1. Here is 1. So whose derivative equals 1? Not x, because here the integration variable is y. The differential here for this integral, the differential is about y. So whose derivative equals 1? That means whose derivative about y equals 1. So which is y, right? You take the y, you take the derivative for y about y, which is equal to 1. So this is y. Then you have a constant c, right? And a constant c will be absorbed by the right side, right? The right side also has a constant c. So it will be absorbed here. So we don't write down the constant c on the left side. Okay, so this is the arbitrary constant. Then here the left side is also arbitrary constant. If you combine together, would be an arbitrary constant. So this would be a solution. And this solution is called the general solution. Okay. So, but we know that this problem, you have infinitely many solutions, right? But if we add one more condition, we can determine this constant c, right? Okay, so here let's look at continue that example, right? We have dy over dx is equal to what? Equal to 2x, right? And we know that we add another condition. When x equals 0, y equals 1. Okay. So this kind of problem, we have the differential equation and we have this condition. This condition is called initial condition. Initial condition. So this problem is called initial value problem. Sometimes we call it IVP. Okay, so how to solve it? So we still start from the beginning. We multiply dy over dx equals 2x. So we multiply dx on both sides. This is dy equals 2x dx, right? Then we integrate on both sides. Then the left side would be what? Equals to not x, it's equal to y because the variable is y, right? The right side would be would be x squared, right? The x squared, the derivative equals 2x. So it's plus, don't forget a plus constant c. So now we want to use this initial condition to determine what is c. The initial condition says y when x equals 0, y equals 1. Okay, so y equals 1 when x equals 0, 0 square plus c. So this tells you that c equals 1. So we have the result y equals x squared plus 1. So this is your solution. If we have this initial condition, then we will have a unique solution. Okay?